Oh yeah, everybody, let's get it started. How we doing, everybody? Out there in the beautiful world. It's your boy, it's Joey. Let's get it started. Oh yeah, we're gonna have some fun today. We're gonna be doing some IPv6. We all love some IPv6 in our life. It's your boy Joey. How we doing, everybody?
Oh yeah. Ooh, we're gonna have some fun today. It's gonna be a talent. We're gonna be doing some IPv6. Oh yeah. Check the person down. So much fun with this right now, as you can clearly see. Alright, everybody, let's get started. Let's get serious. Let's jump into this. This is gonna be a fun one. My mind is gonna explode out of my head.
Oh boy, guys, we're having too much fun. We are having too much fun with all of this. There's a little slice of awesomeness right there, guys. I never freeze. Alright, put this out to the side. That was fun. Hope you guys love putting up with my antics. Alright. This a little bit. Alright. Put that to the side. Alright. How we doing, everybody? Hello? My thingies going off. All my thingies are going off all at once. Alright, everybody, let's get started. Alright. Again, like we talked about on Friday, I hope you guys had a good weekend too. I had a pretty decent weekend. Did some updating, guys. So I got some stuff for you guys. Again, it's part of the Discord. Like I said, I was gonna be a lot of this stream. Well, a part of this stream was gonna be integrating integrating with Discord as well. So what I did was and you don't even, I mean, it would be helpful if you had GitHub, but you don't necessarily need GitHub to be part of, to at least review what I've added to the Discord. So what I pretty much did is now when I'm be working in Cisco Modeling Lab. So if you're familiar with Cisco Modeling Lab, you know what I'm saying, you know it's an emulator and it uses real Cisco images. So what's cool about Cisco Modeling Lab is I can download the actual lab into a YAML file. So I can take every device's configuration and download that into one configuration file. And what I did is again, if you join the Discord, if you haven't joined the Discord and if you're interested to, all you gotta do is to hash the ! Discord in the chat, and there'll be a link for you guys to join the Discord and stuff like that. There's a rules, things that I have that you guys will have to review and stuff like that. And there's a welcome page that you guys can select roles and stuff like that for yourselves. But after you get through all that, you'll see there's a packet tracer channel that I've been putting my packet tracer labs in, and then there's also a Cisco. And this is what I worked on this weekend. There's a new Cisco Modeling Lab channel in there, and what I did is I made a hook between GitHub and Discord. So when I upload the Cisco Modeling Lab configuration file up to my GitHub repository, you'll be able to see that populate in that channel on my Discord. And like I said, you don't per se need to have an account, a GitHub account to actually view it. And that's why I wanted to do it, because I didn't want to just put straight YAML files on my Discord, and then have you guys, you wouldn't, like, say if you were on your phone, you wouldn't actually be able to, you might be able to open it. Depends on, depending on what kind of programs you had on your phone. I have some text editor programs on my Apple phone, but not everybody has those types of apps and stuff like that on their phone. And not everybody's gonna want to download a YAML file off of some guy's Discord. I understand. I get that. So what I've done is what all you have to do is when you see that Cisco Modeling Lab, when you see that GitHub message come through on that Cisco Modeling Lab channel, you just click on it. It's just a hyperlink, and it brings you over to the initial page of GitHub. And then you can actually once you scroll down, again, you don't need an account or anything like that. You just scroll down, and you can actually see in clear text my configuration on all the devices in Cisco Modeling Lab, which is pretty neat. And that's what I wanted. That's what I wanted for it. That's the kind of integration I wanted for it. So you guys can actually see for yourselves and take it away, and then you guys can implement that into Packet Tracer too. You know what I'm saying? Because you'll be able to have that entire configuration file, and you can take it with you, and you can, implement that anywhere else. If you're into network automation, or if you've used Ansible or anything before, it's an actual YAML file too. So you can actually you can use that right in a Ansible playbook. You know what I'm saying? Because it is a YAML file, and that's what Ansible uses and stuff like that. And and again, you can just copy and paste that into your actual networking device too at the same time. So there's so many other things you can do with it too. And if you have GitHub, you know what I'm saying, there's a little bit more integration that goes along with that too as well. But again, you don't need to have GitHub or anything like that. But yeah, so that's what I worked on, and stuff like that. I thought it was a pretty I thought it would be a pretty neat thing to add as well to everything else that I've been trying to add to this to the stream and stuff like that. So you know what I'm saying? Again, check it out. You know what I'm saying? So today, guys, we're gonna be getting into IPv6 here today. Which should be pretty interesting. I'm looking forward to it as much as I've been nearly dreading, you know what I'm saying, spending some time with IPv6. It's something we have to do, and something that is super important to the studies here. So you know, we guys gotta bear through it, get through it, and we'll be fine. We'll figure it out. I also wanted to you know, I'll have to do a poll and stuff like that, but I've been thinking about how I want to start DevNet studies, because you know, like I've talked to you guys before, is we're going to be rolling from CCNA right to the DevNet Associate exam, and I was thinking about this weekend on how to actually roll into that while not taking away from what we've been doing with CCNA. I do have some ideas. Obviously, time's a crunch for me, because obviously I do, you know, I mean, if you guys have been following me for a while, I do, you know, my time schedule is a little bit tight because I work, you know what I'm saying, I'm working full time now. I'm a full-time student too as well. And then obviously the stream takes a lot of my time as well. Well, the CCNA stream as well takes a lot of my time, and I don't want to bear off course, because that will I don't want to not do this 5 days a week as we've been doing it, because that would extend the time out for the actual exam itself. So I was kind of thinking about the weekends with doing, you know, segregating that time for DevNet studies over the weekends. But you know, you guys tell me. Again, I might be putting myself in, you know, putting too much on my plate, but I may be able to handle it. So you know, I want to hear back from you guys to hear, you know, how, you know, if you think it would be a smart decision for me to try to add that to the plate. Again, given my plate is already full already, but you guys tell me. So let's kind of just dive. I got my mics up. I hope you guys like the voice changer thing. That was pretty neat. I was playing again. That was something else I was playing around with this weekend, just to add a little bit of a comic value to the stream. I did. I know. Last week, guys. I was kind of fumbling the football a little bit with zooming the stream on the command lines and stuff like that. So I added a couple zoomed scenes to the to my scene category here. So yeah, if it's not zoomed in enough, we can always zoom it in. So the zoomed in scenes will just we'll play around with how they look, and you guys tell me, you know what I'm saying, give me your feedback on when we get to that point. Give me your feedback on how it looks. We need to zoom in more. Tell me if something's in the way. Just tell me. You know what I'm saying, guys? These my stream setup, guys, it's for you guys. It's for you guys' viewing pleasure. So if there's ever something that doesn't look right, or you think I could tweak or enhance, guys, just tell me. That's, you know, I need that kind of feedback from you guys, so I can progressively make this stream better. So I'm always all ears for feedback too, guys. And again, that's you know, again, if you want to help me out with feedback and stuff like that, join the Discord. I have in there stream suggestion channels, obviously service suggestion stuff and stuff like that. Because feedback's always key, guys. That's how big businesses continue to make bigger and bigger and better advances, because they rely on customer feedback. So I'm relying on you guys to give me your feedback so I can continue to make this better for you guys. You know what I'm saying? Because you guys are a big part of everything. You guys are everything. You know what I'm saying? I wouldn't be doing this if it wasn't for you guys. You guys have been pushing me to continue to get better and better, and to continue to study and push myself to study. And I appreciate every single one of you guys. So, all right, let's get started. Let me kill the Mac music. The music does get distracting, guys. At least when we're studying, it's fine to have it in the beginning, but I find as though we do get distracted. I get distracted at least by the music. So let me drop everything down and move this over here. Hello. All right, I got everything. Everything's still up and running. I've been adding a couple things to everything, so. All right. Well, welcome everybody. All right. So, without further ado, like I said, we're gonna be jumping into IPv6 today. So we're oh, this is part 7, so my labels are wrong. Oh, I'll fix that later. That's no big deal. All right, guys. So part 6, IPv4. IPv4, IPv6. All right. So again, so far, I mean, pretty much like this is saying, so far this whole entire time we've been talking about IPv6, IPv6 subnetting, how to implement that, how to, perform all that addressing and enter that into the command line and stuff like that. We're going to be now getting into all of that with these next couple chapters, guys. All right. And I am going to need a lot of brain power, and so if you guys are out there, if you guys are familiar with IPv6, you know what I'm saying, I'm probably gonna be McFumbling a lot, and I'm gonna be probably relying on you guys to give me advice on if I maybe not capturing an idea properly, or understanding a concept so correctly. So, all right, let's jump into it. Chapter 22, Fundamental of IPv version 6, okay? So this chapter is going to be covering just network fundamentals, configuring and verifying IPv6 addresses as a prefix, okay? IPv4 has been a solid and highly used part of the growth of the TCP/IP in the network, in the internet. For most part of the long history of the internet, and for most corporate networks that use TCP/IP, IPv4 is the core protocol that defines addressing and routing. However, even though IPv4 has many great qualities, it does have some shortcomings, creating the need for the replacement protocol, IPv6. So, again, IPv4, there is nothing wrong, at least from my understanding, there's nothing wrong with IPv4, and IPv4 is it's an easier way to keep, at least because it's so core fundamental and it's what's been taught so heavily so far. There's still nothing wrong with using IPv4 addressing inside of a enterprise network. I mean, we're all still using IPv4. Obviously, it's in the private. It's in a private domain. Some of the public stuff, obviously, the public stuff had to move to support bigger and bigger networks, because obviously we ran out of IPv4 addressing. All right, it extinguished itself because when they first created it, they didn't keep in mind how big it was going to be in the beginning. All right, and that's why they had to create IPv6. They needed a way to create a bigger pool of addresses. All right, and that's what IPv6 came to the rescue and saved the day. All right, IPv6 defines the same general functions as IPv4, but with different methods in implementing those functions. For example, both IPv4 and IPv6 define addressings, the concepts of subnetting larger groups of addresses into smaller groups, headers used to create IPv4 and IPv6 packets, okay, and the rules for routing those packets. At the same time, IPv6 handles the details differently. For example, using a 128-bit. So instead of using a 32-bit like an IPv4, we're now going to be using 128 bits. So we have 128 bits to play around with instead of just 32 bits. So you can imagine the enormity, how large IPv6 is. IPv4 already, just with those 32 bits, IPv4 already was huge. Now with 128 bits, like we're going to be working on with IPv6, it is, it's in the realm of magnitude times what IPv4 was. Okay, so just like I said, rather than the 32-bit of the IPv4. Okay, this chapter focuses on the core network layer functions of addresses and routers. This first section of this chapter looks at the big concepts, while the section looks at the specifics of how to write and type IPv6. Okay, so let's kind of do this already quiz. Let me just take a sip of coffee. All right. Which of the following was a short-term solution to the IPv4 address exhaustion problem? So, what did they do to try to help the exhaustion of the IPv4 problem? So, obviously, IPv version 6, that came to the rescue, but it's pretty much saying, like, what was the following short term? IPv6 was obviously the long-term solution, which is the current solution. All right, but the short term, at least from what we've read so far, it was NAT and PAT, network address translation and port address translation. Okay, NAT and PAT. So what that takes is it pretty much says one IPv4 address and it to many IPv4 addresses to one. I believe you can support in the realm of like 1,600. I think it's 1,600 IPv4 addresses to one address. So it's pretty much you have your public, and this is what your home routers and everything else does. So you have your home router, all right, and you have that one public facing IPv4 address from your ISP, and what your home router is doing, it's doing NAT and PAT, because when you get your IPv4 address from your DHCP server, say, all right, that address that you have on your IPv4, that address that you have, say, on your PC, your laptop, phone, or whatever, that's not publicly facing. That's a private address. When you send a packet to your router, it then NAT and PAT, what they're doing is they're taking that private address and obviously saying, okay, well, this PC it's just saying this address needs to be routed out to the internet, okay? But when it comes back, it adds like a tag to it. We're going to be getting into more NAT PAT as we continue on. But it adds like a tag to it and says, okay, well, I understand that now I got to route this packet out to the public, but when it comes back, I'll know that when the packet comes back, it's going to have this tag on it, and I'll know where to send it to. Do I send it to 192.168.1.50 and just instead of sending it to whoever, you know what I'm saying? So that's what NAT and PAT kind of does. Again, we're going to get into more NAT and PAT description, but let's go with one. Kind of put it over here so you guys can see me. Where is it going to not be in the way? All right, we'll put it over here. Right, so we're going to say 1. We'll say Charlie. All right, a router receives an Ethernet frame that holds an IPv6 packet. The router then makes a decision to route the packet out a serial link. Which of the following statements is true about how a router forwards an IPv6 packet? The router discards the Ethernet data link header and trailer of the receiving frame. The router discards the Ethernet data link header and trailer of the Ethernet frame. Sounds pretty much like how IPv4 does it, and I would say yeah. The router makes a forwarding decision based off the packet. The router makes a forwarding decision based off the packet's source IPv6 address. The router keeps the Ethernet header and encapsulates the entire frame inside of a new. Before sending it, the router uses the IPv4 table when choosing. Router discards Ethernet data link header and trailer of the receiving frame. Do I have to choose 2 answers or 1? The router makes a forwarding decision of the source. The router keeps the. Let's go with A on that one, guys. All right, similar to like how IPv4. If a router was to receive an IPv4, well, if a router was either way, when a router receives a frame, it's going to de-encapsulate that frame. It's gonna discard that Ethernet header and trailer. It's gonna take a look at that packet. So either way, even if it's an IPv4 and IPv6, it's going to then re-encapsulate that packet inside of a new, HDLC or header and trailer or whatever you have you. You know what I'm saying? Wherever it's going to be routed. So let's go with 2. Let's go with A on that one. All right. Which of the following is the shortest valid abbreviation for FE 8.000000100 123. Now, I want to say when we have all zeros, we can abbreviate that all the way down. But it's zeros to the, I gotta remember. I think it's all the zeros from the left. So if we have all the zeros from the left, we can remove those zeros, but any zeros to the right, we have to keep. So if that is the case, then it would be A. Because any zeros to the right, so 80, obviously we would have to keep that 0, but all these zeros we can abbreviate down, but then 100 we would have to keep. So let's go with A on that one, too, guys. All right. Which of the following is the shortest valid abbreviation for 2000? So we have 2,345, 6,789. Let's go with B. Let's go with B on this one, guys. Again, I'm just using what I think is right. I'm not too explicitly sure yet. All right. Just jump over. Just making sure that anybody in YouTube, if they're going to be chatting it up, then I'm monitoring them in chat too as well. All right, which of the following which of the following unabbreviated version of IPv6 addresses, which of the following is an unabbreviated version? Okay. Let's figure this out, guys. So we have 2001. Delta Bravo 08 4 0200 228. What matches that? So that could be okay. It's this one. It's A. It's A. Let's go with 5. Let's go with A. All right. Which of the following? Let's not scroll all the way down. I don't see the answers yet. Which of the following? Which of the following is the prefix for the address 2000? Yep. Assuming the mass is 64. All right. Which of the following is the prefix? The prefix giving that address. So what do we got? Given that the mask is 64. So we got each bit has how many bits are in each? How many bytes are in each bit? At least on this one, so it'd be 4. So 128. So let me just do some quick math, guys. So 16. So each one has 16. So So 1, 2, 3, 4. So right here. So if it had the subnet mask of 64, it's pretty much saying that this right here is the actual network. Okay. So then what matches that? So we can address that down to A, right? I believe it's A. Let's go with A on that one, right? Yeah, let's go with A. All right. So how I figured that was, guys, is so there's 16 in each of one of these octets, these IPv6. I don't know if they call them octets because octets means it wouldn't be called octets because octets means 8. There's probably another terminology that we're going to learn. But each one of these is representing 16 16 byte bits. Bits. 16 bits. All right. So each one of these is representing 16. All right. So 16, obviously 16, and then another 16, and then another 16, giving us the subnet mask of 64. All right. All right. And then obviously we can abbreviate all these zeros out. All right. All right. I believe that's how IPv6 does it. I could be wrong. I've been wrong before. And I am wrong. Okay. All right. This is how we learn, guys. All right. All right. So we got one right. We got two right. This should be D. We got 4 right. We got 5 right. So we did all right. And then and then we got that wrong. And then we got, this is Charlie. That's an awful seagull. Ah! Go back. I thought I erased it forever. Thank goodness. This should be Charlie. Okay. Now let's go take a look at what we did. So, all right. So that's implying that we leave the zeros. That's implying that we leave the zeros in each field. Okay. We did get this right. So we did get this right. All right. That's cool. All right. So we're tracking, at least we're tracking on some of the fundamentals. So we're not too far off. Not too far off. And then B, we were right here. So I'm not too far off on some of my at least understanding. So, and then I got this one wrong. Let's take a look at how I got that one wrong. I'm slightly confused. I guess I'm slightly confused. I guess where I'm getting stumped at is, if you could see, it's removing these zeros on some of them, but then it's pretty much telling me that I shouldn't have removed those zeros. Now, there could be, it may just not be allowed. 4, we got 4 right. Why did I get 4 right? The shortest. So again, I have it. I'm anything from the, at least from my understanding so far, is anything from the left, any zeros from the left, you can remove to abbreviate. We're just talking about abbreviation. But when it's doing that, when it's removing the zeros entirely, and then when we go back to D3 here, and it's saying that I should have just left those zeros there. Am I not allowed to remove? I don't know. All right. Again, we did fairly well. We only got 2 wrong out of the do I know this already quiz. So we at least have a fundamental understanding of what to expect for IPv6. So, all right, that's cool. All right, let's jump into it now. Let's jump into it now. Head first, guys. Head first. Whee! All right. Introduction to IPv6. IP version 6 serves as a replacement protocol for IPv version 4. Unfortunately, that one bold statement creates more questions than answers. why does IPv4 need to be replaced? If IPv4 needs to be replaced, when will that happen? And will it happen quickly? What exactly happens when a company or internet replaces IPv4 with IPv version 6? And then the list goes on and on. And that's again to the explanation of IPv4 will still exist. It is still always, at least it'll all, I know, I can pretty much tell that, or pretty much can guarantee that IPv version 4 will always be around, at least in the private domain of things. For the simplest reason, it's just easier to use IPv for. It's just easier to rack your brain around IPv version 4 than having to deal with a 128-bit address of an IPv version 6 address. Like, why would you need to implement such a large address pool inside of a private domain, unless you were dealing with an enterprise level domain that you were dealing with, hundreds of thousands of addresses that you needed to be allocated out. Then implementing IPv version 6 inside of that private domain would definitely be probably a answer, but still you could still pretty much do all of that with IPv version 4. But in the public domain, IPv6 is what has to be used because of we just ran out of addresses. There's we're creeping on, I think, 8 billion people in the world, and there's even more probably devices that take IP addresses than that in this world. So I mean, you can imagine the enormity of the pool in which IPv4 just could not cover anymore. So just take a sip of coffee real quick. I'm sorry, but I don't know if you guys, get aggravated when I drink coffees and stuff like that. It's just, obviously, this is my morning type time for me. So this is when I wake up and I'm just getting dinner ready and everything for the kiddos. So I just usually drink a lot of coffee anyways, just getting geared up for the study and then getting geared up for work because I got to follow right up with work for me. So, all right, enough of that. So while the introductory chapter cannot get into every detail of why IPv4 needs to eventually be replaced with IPv version 6. The clearest and the most obvious reason for migrating TCP/IP networks to use IPv6 is growth. IPv4 uses a 32-bit address, which totals to a few billion addresses. Interestingly, that seemingly large number of addresses is too small. IPv version 6, the address to 128 bits. For perspective, come on, don't start Twitch. For perspective, IPv version 6 supplies more than, ooh boy. Let me see what kind of number we got here. Let me see. So that's a million, billion. Is that a Google? That might be an entire Google. Hold on, that might be a. I want to know how big this number is. It's Ninillion. Is that how you say it? Jesus prophesies that. Okay. 10 octillion. There it is. We can name it 10 octillion. So that is 10 octillion. How's that for you? So 10 octillion times as many addresses as IPv version 4. So 10 octillion. So, yeah, that's a big number, guys. I wish I had that in my bank account. Jeff Bezos wish he had that kind of money. All right. Yeah, it's a big number, guys. So, until we reach intergalactic space travel, and we are living on multiple different planets inside of multiple different multiverse universes, we may not have to implement IPv version 8 just yet. IPv version 6 might get us thus far. So, IPv version 6 will get us into the future, guys. The fact that IPv version 6 uses a different size address fields with some different addressing rules means that many other protocols and functions change as well. For example, IPv4 routing. In other words, the packet forwarding process relies on an understanding that IPv4 relies on an understanding of IPv4 address. And to support IPv version 6 routing, routers must understand IPv version 6 addresses in routing. To dynamically learn routes for IPv4 version 6, subnet routing protocols must support these different IPv6 addressing rules, including rules about how IPv version 6 creates subnets. As a result, the migration from IPv version 4 to IPv version 6 is much more than changing one protocol IP, but it impacts many protocols. The first section of this chapter discusses some of these reasons for the change from IPv version 4 to IPv version 6, along with the protocols that match the changes as well. So from DHCP guys whoa, there's so many. Just think of how many actual protocols work in and around on top of inside of IPv4. That change had to take place as well when we started implementing IPv version 6. So there had to have been a lot of working to get this to all work together properly. So, all right, take a quick sip of my coffee. All right. In the last 40 plus years, the internet has grown from its infancy to begin a huge influence in the world. It first grew through research at universities from the ARPAN net begins of the internet in the late 60s and 70s. The internet kept growing fast in the 1980s, with the internet fast growing still primarily driven by research and the universities that joined in that research. By the early 1990s, the internet began to transform, allowing commerce, allowing people to sell services and products over the internet, which drove yet another steep spike upward in the growth of the internet. Eventually, fixed internet access, primarily through dial and digital subscriber line (DSL) and cable, became common, followed by the prevalence of the internet for mobile devices like smartphones. The figure shows some of the major milestones and the general dates. So we have its earliest of beginnings in the late 1960s into the 1970s here. All right. So we have the ARPANET. Is that how you would say that? ARPANET. All right. In the 70s, and then we have some research going on into the early 80s into the early 90s here, and then obviously in the 1990s, which I am a child. Obviously, I was born halfway through the 80s here. I was born in 85 here. But I was a child, pretty much. I grew up in the 90s, in like the beginning of when the internet started to becoming more popular. You know what I'm saying? Um, Obviously, my parents, you know, they were born back in the 40s here, so they really weren't even as much as my father was a technology. He tried to be a technology guy into his later years. Um, you know, the internet really wasn't a thing that they depended on or even needed, I guess. You know what I'm saying? Um, but obviously growing up in the 90s and, you know, starting to be exposed to the internet and what the internet can do, chat rooms, AOL, stuff like that. You know what I'm saying? You would go on your, I remember I was a super, I was a big Spawn. So if you guys remember Spawn, not so many people remember the Spawn comic books made by Todd McFarlane, but I was a huge fan of everything Todd McFarlane was doing back then with Spawn and stuff like that. Just because he had such a great his artistic ability and the way he drew his comic books was super amazing. I just love the story too. It was a great story. Um, but I remember that was the beginnings of when I would go on the internet and I would go to that site that they had. And as basic as it seems now, it was like it was so cool to go on that website. You know, it would be, you know, months before they would even make some kind of slight update to it or put some kind of new bit of information on there. But again, it was really neat to see, to be able to access someone else's page that they were able to put things on digitally, and you be able to observe that. Obviously, things have totally changed now with everything that we have these days. Um, you know, obviously, and then you have the prevalence of fixed internet. So when internet became a big service, you know what I'm saying, when cable companies started, um, you know what I'm saying, serving that up to you with your cable package and stuff like that in the early 2000s, and then pretty much after that happened in the early 2000s, um, it was just commonplace that if you had cable, you had internet too as well. You know what I'm saying? Back again, going back just to the 90s again, you may have had internet, you may have not had internet. You know what I'm saying? I was maybe, you know, I grew up in a housing development, but my father always wanted us to be privy with technology and whatnot. So he would do what he could to make sure that we were at least getting exposed to what was coming. Um, so we had to dial up and stuff like that. It was neat. It was neat to just experience that back then. To in comparison to what it has obviously turned into now, where everybody's mobile device is hooked up to the internet. You know what I'm saying? You can walk out your house, walk down the street to the local grocery store, and you still can be streaming on the internet. You know, watching your favorite YouTube videos and whatnot. Um, and obviously, it's just grown immensely, and that's why obviously they had to create IPv6 because things have gotten so big. So the incredible growth of the internet over a fairly long time created a big problem for public. So remember, public IPv version 4 addresses. The world was running out of addresses. For instance, in 2001, the IANA allocated the final slash pretty much the Class A address block, the same size as the Class A network. So yeah, so Class A, allocating the final Class /A block to each of the 5 region internet registries. So the regional internet registries, the IRA, the IRR, the IRR, IRR, RIR. I love the acronyms. Um, at that point, the RIR, the registry internet, the regional regional internet registry could no longer receive new allocations of public addresses for the IANA to turn around and assign smaller address blocks to companies or ISPs. At that point in 2011, each of the 5 regional internet registries, let's keep saying that, still had public addresses to allocate in it or assign. However, that same year, the Asian Pacific became the first regional internet registry to exhaust its available IPv4 address allocations. And in late 2015, the North American announced that it had exhausted its supply. So in 2015, when we revised this chapter in 2019, the IANA considered all regional internet registries except for the African to have exhausted their supplies of IPv4 addresses, with the African expect to run out of IPv4 addresses during the year of 2019. So when this book was written this book was written in early 2019. It was just pretty much saying that the African region was gearing up to run out of IPv version 4 addresses in 2019. So when this book was actually written. All right, these events are significant in that the day has finally come in which new companies can attempt to connect to the internet, but they no longer supply IPv4 ignoring IPv4 version 6. Their only option will be IPv version 6 because IPv4 has no public addresses left. Okay. You can track the IRIN's progress through the interesting transition in the history of the internet at its IPv4 site. Okay, so that's just the website there, guys, that you can look into the history of IPv version 4. All right. Even though the press has rightfully made a big deal about running out of IPv4 addresses, those who care about the internet knew about this potential problem since the late 1980s. The problem, generally called the IPv version address exhaustion problem, could literally have caused a huge growth of internet. Could literally have caused the huge growth of internet in the 1990s to have come to a screeching halt. Something had to be done. The IETF came up with several short-term solutions to make IPv4 addresses last longer, and one long-term solution, IPv version 6. However, several other tools like network address translation, so NAT, all right, and classless interdomain routing, CIDR, all right, help extend IPv version 4's life over another couple decades. IPv version 6 creates one more permanent and long-term solution, replacing IPv version 4 with a new IPv version 6 header and a new IPv version 6 address. The address size supports a huge number of addresses, solving the addressing shortage problems for generations, we hope. So like I said, until I think IPv version 6 will get us into the to the realm when we're intergalactic space traveling creatures. Hopefully. The figure shows some of the major address exhaustion timing. So we have the RFC 791 in the early 80s. Concerns of the address IPv4 address exhaustion came about in the early 90s. So and again in the early 90s they came up with NAT and CIDR, and then IPv6 RFC started to hit again in the mid 90s. Then when NAT and CIDR differ on the need for IPv version 6 only, 2000s, NAT Insider kind of saved the day, pushing off the need to implement IPv version 6 for a little bit longer. And then obviously, we had what we just talked about with the IANA and the IRA, and exhausting their final IPv version 4 addresses. And then IPv version 6 replaces IPv version 4 someday in the near future. Totally. We're talking totally replaces IP version 4. All right, that day has not come yet. And obviously it will someday, but again, in the private domain, I still believe honestly that the IPv version 4 addressing will still be used in the private sector, just because of it. You don't need 10 octillion addresses for your house. You know what I'm saying? Not yet. We don't have everything. We don't have everything hooked up to the internet in our houses yet. You know what I'm saying? But still, at that, I don't think there's going to be a crazy need to use IPv version 6 in the private domain. Public domain is different, obviously. All right. The rest of the first section explains IPv version 6, comparing it to IPv version 4, on the common features of the two protocols. In particular, this section compares the protocols, including addresses, routing and routing protocols, and miscellaneous other related topics. You might wonder why the next version of IP is not called IP version 5. There was an earlier effort to create a new version of IP, and it was numbered IP version 5. IPv5 did not progress due to the standard stages. However, to prevent any issues because of version 5 had been used in some documents, the next effort to update IP was numbered version 6. So I guess there was an actual version 5, but it never, I guess it just fell through. It just never was completed. How's that? So when they went and revised it, it ended up turning into IP version 6, guys. And that's how we landed on the IPv6. All right. The primary purpose of the core of IPv version 6 protocol mirrors the same process of the IPv4 protocol. That core IPv version 6 protocol, and as defined in RFC 2460, defines a packet concept, addresses for those packets, and the roles of the host and routers. These rules allow the devices to forward packets sourced by host through multiple routers. So they arrive at the connected destination. IPv4 defines that same concept with IPv4 back in RFC 791. However, IPv6 impacts so many other functions of the TCP/IP network. Many more RFCs must define details of IP version 6. Some other RFCs define how to migrate from IPv4 to IPv version 6. Others define new versions of familiar protocols or replace old protocols with newer ones. For example, older OSPF version 2 to upgraded OSPF version 3. The older open source shortest path first, OSPF version 2, works with IPv4, but not with IPv6. So a newer version, OSPF version 3, was created to support IPv version 6. Note, OSPF version 3 was later upgraded to support advertising both IPv version 4 and IPv version 6 routes. So there's even a newer update to the OSPF version 3 that supports both IPv4 and IPv6. It's pretty interesting. All right. ICMP upgraded to ICMP version 6, Internet Control Message Protocol. So the ICMP message worked well with IPv4, but needed to change to support IPv6. The new name is ICMP version 6. Okay. All right. OPT replaced by Neighbor Discovery Protocol. So OPT is replaced by Neighbor Discovery Protocol. For all IPv4 address resolution protocol (ARP), all right, discovers the MAC address used by neighbors. IPv6 replaces ARP with a more general neighbor discovery protocol, so NDP. So NDP, neighbor discovery protocol. Instead of address resolution protocol, IPv6 uses NTP, neighbor discovery protocol. All right. If you'd like to go to any of the websites listing the, you can find almost 300 IRCs. Yeah. Okay. Although the term IPv version 6, when used broadly, includes many protocols, the one specific protocol called IPv6 defines the new 128 bit IPv version 6 address. Of course, writing these addresses in binaries would be a problem. They probably wouldn't even fit on the width of a piece of paper. IPv version 6 defines a shorter hexadecimal format. All right, hexadecimal format, requiring at most 32 hexadecimal digits, one hex digit per 4 bits. All right, one hex digit per 4 bits. All right, with methods to abbreviate the hexadecimal addresses as well. For example, the following are IPv version 6 addresses, each with 32 or fewer hex digits. All right. So this is just showing some addresses here. Obviously, some are abbreviated, and this is obviously like a full length, hex. You know what I'm saying? An unabbreviated IPv6 address, abbreviated, and then there might be a couple different stages, because obviously you can see here that's really abbreviated down, and then this is abbreviated too as well, guys. So, all right, the upcoming section, IPv version 6 address formats in conventions, discuss the specific of how to represent an IPv version 6 address, including how to legally abbreviate the hex address values. Like IPv version 6, IPv4, IPv6 defines the header, which places to hold both the source and destination address fields. Comparing to IPv4 and IPv6 header does not make some other changes besides simply making the address field larger. However, even though the IPv6 header is larger than the IPv4 header, the IPv6 header is actually simpler. On purpose to reduce the work done each time the router must route an IPv6 packet, shown in the required 40-bit part of the IPv6 header. All right, so we have 40 bytes by 4 bytes, 40 bytes by 4 bytes. So we have 1616 source destination. So we have class, version class, flow label, payload length, next header, and hop limit. Okay. Very good. Very good. Take a swig of, let me drink some water. All right. As many functions of IPv version 6, IPv6 routing looks just like IPv4 from a general perspective, with differences being clearly only once you look at the specifics. Keeping the discussion generally from now, IPv6 uses the idea as the same as IPv4. So it's the same concept. So it's fundamentally, routing is generally about the same. All right. To be able to build and send IPv6 packets out an interface, end users' devices need an IPv6 address on the interface. End users need end user/host need to know IPv6 addresses of the default router to which the host sends the IPv6 packet. If the host is in a different subnet, IPv6 routers de-encapsulate and re-encapsulate each IPv6 packet when routing the packet. The IPv6 router makes a routing decision by comparing the IPv6 packet destination address to the router's IP routing table. the matched route list directions of where to send the packet. So just like everything that we learned with IPv version 4, guys. Same general concepts. Okay. All right. It's just everything we just need to implement IPv version 6 on the routers interfaces, the default gateways, and everything else that we're doing. We just have to switch up from using one address scheme to the other address scheme. Okay. All right. Note you can take the preceding list and replace every instance of IPv version 6 with IPv version 4, and all the statements would be true of IPv4 as well. So there you go. Again, it's just saying the exact same thing that I did. All right. It's fundamentally, all right. It's apples to apples, guys. Apples to apples. Okay. If you understand of what I'm saying by apples to apples, is it's you're just changing the address scheme. Okay, the address scheme or it's just obviously we're just dealing with bigger addresses. Okay, the concepts. How's that? The concepts. That's what I guess what I'm trying to say. The concepts are the same. We can understand IPv4 routing. We can understand IPv version 6 routing. While the list shows some concepts that should be familiar from IPv4, the next few figures show the concepts with an example. First, the figure shows a few settings on a host. The host PC has the address of 2345, all right, ::1. PC1 also knows the default gateway, 2345, ::2. Both values are valid abbreviations of real IPv version 6 addresses. To send the IPv version 6 packet to PC2 on the other IPv4 subnet, PC1 creates the IPv version 6 packet and sends it to R1, PC1's default gateway. All right. And there we go. All right. Again, pretty much the same thing. It's just we have to just learn how we're going to be figuring out these addresses and whatnot, and how to create these addresses, subnet these addresses and whatnot. All right. The router R1 has the same tasks to do when forwarding the IPv version 6 packet, but for now, focus on the work R1 does related to encapsulation, as seen in the figure. R1 receives the incoming data link frame and extracts, de-encapsulates the IPv6 packet from inside of the frame, discarding the original data link header and trailer. So again, it does the same thing. It gets rid of that Ethernet data link header and trailer. All right, de-encapsulation. All right. At step 2, once R1 knows to forward the IPv version 6 packet to R2, so R1 knows to forward it to R2. R1 adds the correct outgoing data link header and trailer to the IPv version 6, encapsulating so again, it's re-encapsulating that packet, all right, the IPv version 6 packet now inside of a HDLC, so a high-level data link control, Ethernet header and trailer, okay, and then forwards that out to R2, all right. All right. IP version, when routing, when a router like R1 de-encapsulates the packet from the data link frame, it must also decide what type of packet sits inside of the frame. To do so, the router must look at a protocol type field in the data link header, which identifies the type of packet inside of the data link frame. Today, most data link frames carry either IPv version 6 packets or IPv version 4 packets. To route an IPv version 6 packet, a router must use an IPv version 6 routing table instead of an IPv version 4 routing table. The router must look at the packet destination, the IPv6 address, and compare the address to the routing current IPv6 routing table. The router uses stumbling over my own words. The router uses the forwarded instructions to match the IPv version 6 route to forward the IPv version 6 packet. So again, it's just looking at its routing table. It knows that out of serial 0000, obviously it's going to be sending, that packet to its next hop, which is R2. All right. Comparing. Next, note again, the process works like IPv version 4, except that the IPv version 6 packet lists the IPv6 address, and the IPv4 routing table lists the routing information for the 4 IPv version 6 subnets. Okay, called prefix. Okay. Finally, in most enterprise networks, the routers will route both IPv version 4 and IPv version 6 packets at the same time. That is, your company will not decide. That is, your company will not decide to adopt IPv version 6 and then late one weekend night turn off all IPv4 and enable IPv version 6 on every device. What? Let me read that again. Sometimes this book, I'm telling you, it's so hard to read sometimes. All right, that is, your company will not decide to adopt IPv version 6 and then late one weekend night turn off all IPv4 and enable IPv instead of whatever. Instead of IPv version 6 allows for a slow migration, during which some of all routers forward IPv version 4 and IPv version 6 packets. The migration strategy of running IPv version 4 and IPv version 6 is called dual stack. So the terminology dual stacks comes from running both IPv version 4 and IPv version 6. Okay. All you have to do is configure the router to route IPv version 6 in addition to existing configurations for the IPv version 4 packets. Okay. IPv6 routing protocols. IPv6 routers need to learn routes for all the possible IPv6 prefix subnets. Just like in IPv4, IPv6 routers use routing protocols which with familiar names, generally speaking, with familiar functions. None of the IPv4 routing protocols could be used to advertise IPv version 6 routes originally. They all required some kind of update to add address protocols and rules to support IPv version 6. Over time, routing information protocol RIP, open shortest path first, all right, OSPF, enhanced interior gateway routing protocol, EIGRP, border gateway protocols, BGP, were all updated to support IPv version 6. The list of the names of general routing protocols with some few. Okay. So we have RIP, which is pretty much not in use much longer. Not too many people are using RIP. All right. Most people are using OSPF, ERGRP, and obviously BGP, which is the big internet. Okay, that's what's routing between autonomous systems. Okay, autonomous nodes, autonomous systems. Okay, OSPF and ERGRP are more internal type routing protocols, where BGP is like external. There are some versions, I believe, of external ERGRP, but for the most part, no, there isn't. It's all BGP. I believe there's another exterior routing protocol, but for the most part, it's BGP. Okay. All right. In addition, these routing protocols also follow the same interior gateway protocol, IGP, and exterior gateway protocols, EGP, conventations, as their IPv version 4 cousins. RIP, ERGRP, and OSPF version 3 act as interior gateway protocols, advertising IPv4 6 routes inside of an enterprise. As you could see from this introduction, IPv6 uses many of the same big ideas as IPv version 4. Both define header and the source destination addresses. Both define the routing of packets, with the routing process disregarding old data link header and trailer when forwarding the packet. And routers use the same general process to make and routing decisions compared to the packet destination IP address and to the routing table. All right, the big difference between IPv version 4 and IPv version 6 revolves around the bigger IPv version 6 addresses. The next topic begins to look at the specific of those IPv version 6 addresses. All right. Address IPv version 6 address formats in conventions. All right. The CCNA exam requires some fundamental skills in working with IPv version 4. For example, you need to be able to interpret IPv4 addresses like 172.21.73.14. You need to be able to work with prefix style masks like /24 and interpret the means which use the particular IPv version 4 addresses. And you need to be able to take an address in mask like 172.21.73.14/25 and find the subnet IT. All right, the second major section of this chapter discusses the same ideas for IPv version 6. In particular, this section looks at how to write and interpret an abbreviated 32-bit IPv4 6 address, how to abbreviate an IPv version 6 address, and how to interpret the abbreviated address, how to interpret the prefix length mask, how to find the IPv version 6 prefix subnet ID based on an address and prefix length mask. The biggest challenge with these tasks lies in the sheer size of the numbers. Thankfully, the math to find a subnet ID, often a challenge for IPv4, is easier for IPv version 6, at least to the depth discussion in this book. Okay, representing full unabbreviated IPv version 6 addresses. IPv version 6 uses a convenient hexadecimal format for address. To make it more readable, IPv version 6 uses a format with eight sets of 4 hex digits, which each of the 4 digits separated by a colon, for example. All right, so here's a IPv version 6 address here. For conversations, the author uses the term quadret, quartet. There we go. For one set of 4 hex digits with 8 quartets in each IPv6 address. Note that the IPv version 6 RFC does not use the term quartet. Yeah. Sure. All right. IPv version 6 also have a binary format as well, but thankfully for the most of the time you do not need to look at the binary version of the address. However, in those cases, converting from hex to binary is relatively easy. Just change each hex digit to equivalent 4-bit value listed in the table. All right. So hex to binary. That's pretty easy. And it goes what? It's 16, right? Yeah. 2, 3, 4, 5, 6, 7, 8. Yeah. It goes up to 16. So F. So when we see F, that's represented 16 right there. So after 9, so A, 10, 11, 12, 13, 10, 11, 12, 13, 14, 15, 15. Yep. A. Yep. Okay. All right. Makes sense. All right. Abbreviating and expanding IPv4, IPv6 addresses IPv6 also defines ways to abbreviate or shorten how to write or type in IPv6 addresses. Why? Although using a 32 digit hex number works much better than working with the 128-bit binary number. 32 hex digits are still a lot of digits to remember. Recognizing in command output and type on the command line, the IPv6 address abbreviation rules let you shorten these numbers. Computers and routers typically use the shortest abbreviation, even if you type all 32 hex digits of the addresses. So even if you would prefer to use the longer abbreviated version of the IPv6 addresses, you need to be ready to interpret the meaning of the abbreviated IPv6 as it listed by the router or host. This section first looks at the abbreviation address of that expanded addressing. So it's pretty much stating that even if you would like to write it with the 32-bit hex number, hex digits, computers, routers, and everything else are going to abbreviate that in their outputs. So that's the reason why we have to learn how to understand and interpret a abbreviated IPv6 address because of hey, what's up? How we doing out there? So that's the reason why we need to learn how to interpret and abbreviate that. I love your birds. All right. Abbreviation of IPv version. I want to sleep. You know me both. Abbreviating the IPv6 addresses. Two basic rules let you or any computer shorten an IPv version, abbreviate an IPv6 address. Oh, you might be home early. Woo, 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 woo. Shout out to my baby. She might be home early. That's what I'm talking about. All right. Inside the quartet are 4 hex digits. All right. Remove the leading zeros. So again, any zeros from the left. All right. Zeros on the left side of the quartet. In the three positions on the left. Note at this step, a quartet of 000 would leave you with a single 0. All right. So once we get over to like writing these addresses down, guys, we'll move over to the whiteboard so we can write these out, because again, it's better for me to write these things out. Find any string of 2 or more consecutive quartets of all hex zeros, and replace those sets of quartets with the double colon. That means colon means 2 or more quartets with all zeros. However, you can use colon only once in a single address, because otherwise the exact IPv6 might not be clear. All right. Yay. So what's that stating is we can only use the colon once in the abbreviation of our address. All right. That's fine, baby. I'll talk to you in a little bit. All right. For the example, consider the following IPv6 address. The bold digits represent digits in which the address could be abbreviated. All right. So what it's pretty much stating here is these zeros. So if we had these two leading zeros here, we could abbreviate this by colon. So we would have Fox Echo 00 colon 1 colon 0 colon 0 colon 0 5 6. And that's pretty much what they did here. All right. So for this is bold. All right. Applying the first rule, we would look at the 8 quartets independently for each, removing all the leading zeros. Note that the 5 quartets have 4 zeros. So for these, removing all 3 zeros, leaving the following value. Yep. While this abbreviation is valid, the address can be abbreviated more. Using the second rule, in which case this 2 instances exist where more than one quartet in a row has only a 0. Pick the longest such sequence and replace it with the colon, giving you an even shortest legal abbreviation. So where did they do? Say they did that here. Oh, I see what I'm saying. I get it now. I get it now. Alright. While FE 00 colon 0 colon 0 colon 1 colon 5 6 is indeed the shortest abbreviation, this example happens to make it easier to see the 2 most common mistakes when abbreviating IPv6 addresses. First, never remove trailing zeros. In a quadret, zeros on the right side of the quadret. In this case, the first octet, quadret. I can't say octet. Quadret. All right, quadret, not octet. Quadtet of the FE00 cannot be shortened at all because of the 2 trailing zeros. Okay. So the following address, which begins now with only FE and the first quartet, is not correct abbreviation of the original IPv6 address. Okay. The second common mistake is to replace all series of the 0 quartets with the double colons. For example, the following abbreviation would be correct for the original IPv6. All right, so this cleared up a lot for me. The reason for the abbreviation is correct, incorrect, is now you don't know how many tets of zeros to substitute to find the original abbreviation. Oh, okay. So that makes sense. So that enlightened me on where I was making the original mistakes when we were looking at the abbreviated and unabbreviated addresses. All right, expanding abbreviated IPv6 addresses. To expand on the addresses back into the full unabbreviated 32-bit number, use 2 similar rules. This rules basically reverse the logic of the previous 2 examples. In each quartet, add leading zeros as needed until the quadret has 4 digits, hex digits. If a double colon exists, count the quartets currently shown to total should total should be less than 8. Replace the colon with multiple quartets of 0000 so that 8 total quartets exist. The best way to get comfortable with this address and abbreviation is to do so yourself. The table lists some practice problems with the full 32-bit. All right, press abbreviation to the right. The table shows. All right. You know what? Let's do this then, guys. Let's get over to let's get over to the whiteboard. Let's do some of these on the whiteboard, guys. All right. That way we can get some practice with doing these, guys. Physical practice is the best kind of practice. Let's get physical, baby. Coffee is cold now. I like iced coffee, but I don't like hot coffee that should be hot. I don't like hot coffee that's cold. How's that? Cold hot coffee is a no good, man. Let's get physical. Stay there, monitor. Stay there. There's me mouse. All right. Let's do the first problem. We have 2340 : 1 2 3 4 : 0 0 1 0 : 0 1 0 0 : 1 0 0 0 : A B C D : I'm already running out of room. All right. I'm already running out of room. 0 1 : and then end it with 1 0 1 0. Okay. So what we can do here is pretty much, so we can't remove this 0, so this 0 has to stay. We can abbreviate that down. We can abbreviate those two down. We can abbreviate that one. We can't abbreviate nothing there. We can abbreviate one there. So that gives us the address. The abbreviated address 2340. All right. And do we have any other? So we can abbreviate this down to 0 0 : 1 0 : all right, 100 : 1000 : A B C D : all right, 101 : 1010. All right, so that's the first step of abbreviation. Then we can abbreviate it down one more time. Was 0, and then this would be : 10 : 100 : 1000 : A B C D : 101 : 101. All right, so that would be the abbreviated version of that address right there, guys. All right. So what we can pretty much, and I'll put it up on our board so you guys can see it. I'll make this a bit smaller so we can actually see it. 2340 : 10 : 100 : 123 : A B C D : 101 : 1010. All right, so that would be the abbreviated address for for this IPv version 6 address right here, okay? So we were able to remove this entire quartet. We were able to remove this entire quartet here, obviously because we had all zeros, and then using the second rule, we can remove those, all right, and then abbreviate it down even further. But this would be the ending. This would be the least. This would be the most legally abbreviated version of that IPv6 address that we have there. Okay, now let's do the second address. And that's unabbreviating it. So we have to unabbreviate this address now. Okay, so we have to reverse it. So we have 30 colon C colon echo 2 colon 3 4 5 6 colon C B C colon B 0 B 0. Okay. All right. So here we go. Let's do this now. So when I look at this, this has 4 in its quartet. 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 This only has 3. So we need to. So we had, most likely, we had a leading 0 here. So we had a leading 0 there. And then this has 4 in its quartet. So we have 2, 3, 4, 5, 6. All right. All right. So again, we need 8. So, and then then it's ending, and this is where it's going to get us. It's ending with this colon here. Okay. But we need 1, 2, 3, 4. Colon 1, 2, 3, 4. All right, to give us 8 quartets. So 1, 2, 3, 4, 5, 6, 7, 8 quartets here. All right. So to unabbreviate that forward, that's what that address would look like. Let's write that out. So we have 30 alpha 0 colon A CD colon echo foxtrot 1 2 colon 3 4 5 6 colon 0 echo bravo Charlie colon bravo 0 bravo 0 colon and then 1 2 3 4 1 2 3 4. All right, so that would be the unabbreviated version of that abbreviated IPv6 address there. All right, because remember, we need 8 quartets, 8 quartets, okay? All right, now let's take a look at the next one. Boop, I dropped it. All right. And what is it? 222 333. Okay, we can almost, we can just kind of just knock this out of the park here. Let's do this. So let's abbreviate this down. We have 222 colon 3333 colon 4444 colon 5555 colon. All right, since we have two quartets with leading zeros, so we can abbreviate that with colon. All right. Yeah, we can abbreviate that with colon. All right. And then 6060 colon, and then we can remove that leading 0, and then 707. Doesn't give me, I thought it was going to give me the answers. It doesn't. That's good. Now let's do this one now. So this one, again, this one should be real simple too as well. We could just kind of blast this one out too. So this would be 3210 colon 1234 colon 1234 colon 1234. That's 4 1 2 3 4 quartets. 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay. Now that gives us the 8 quartets that we needed to finish off our address here. Okay. And then let's do this one now. So we have 210 Foxtrot colon, and how many? So we can replace the three leading quartets of the zeros, since we have this is the most. So these 3 right here is the biggest portion of the zeros that we have. So we can replace that with colon. All right, and then we have Charlie, 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 colon, all right, 0, colon, 0, colon, and then delta, all right. So that would be the legal abbreviated portion of that address right there. Okay. Let's do this other one. Now we have to abbreviate this back. Okay. So again, what we're seeing here is there's a quartet here that had leading 0. So we have 1, 2, 3, 4. So we had a couple quartets. All right. So let's just do this. So let's do 3, 4. Bravo Alpha colon 1 2 3 Bravo colon 1 2 3 Bravo colon, and then so that gives us 1 2 3 2 1 2 3 4. So that's 4 1 2 3 4. It's 5 1 2 3 1 2 3 4. That's 6. Right, 1 2 3 5 6 colon 1 2 3 4 7, and then 0 0 2 0. All right, and that would be the unabbreviated. That would be the how to unabbreviate that address back. Okay, because now we have 1 2 3 4 5 6 7 8 quartets now. Okay, so this abbreviated portion, again, that abbreviated portion here, all right, that turns now that into this abbreviated portion here. So that abbreviated portion was pretty much saying that there was 1 2 3 4 quartets that had all leading 0s in it. All right, and then ending obviously with the 2 0. All right, to finish it off. All right, and that final quartet there. All right, let's do this other one. And we gotta abbreviate this down. So we have FE0. Remember, only leading 0s can be abbreviated down. Trailing 0s cannot. And what do we got? 1 2 3. Dead beef. That's funny. So we can abbreviate that with colon. All right, and then dead. You know what's funny? Dead beef. That's actually. Where did I discover that? That's in something else. Dead beef. That's an Easter egg for something else. I gotta remember that. All right, that came from something else. Dead beef. Dead beef. Where does that come from? Why do I know that? That's like an address or something. I forget what it's from, but it's something. It means something. There's something else to it. I forget. Oops. So that would be the abbreviated part of that address right there, okay? All right, I'm feeling, now that we did this practice, I actually feel more confident on at least abbreviation and unabbreviating IPv version 6 addresses here. Again, I just wish it gave me the answers, but it doesn't. All right. There is one more. I guess we'll just do it. Just clear the board. So let's do this. The very last one, guys. All right. So we have FE. E. We have a couple of missing quartets here. So we have 1, 2, 3, 4, 5. So there's 3. It's going to be 3 quartets with leading zero. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, and then face, colon, bath, colon, B, B, E, colon, bath. 1, 2, 3, 4, 5, 6, 7, 8 quartets now. Okay, so that's the unabbreviated version of this abbreviated address there. Okay, so remember, leading zeros can be abbreviated all the way down, and if you have multiple leading zeros in continuous and pretty much in continuous quartets, the most I was gonna say, the quartets can be the ones that have the most quartets with the leading zeros can be abbreviated down by colon. Oh, good looks on the follow. Tycho Bomb. Is that Tycho Bomb? Tycho Bomber. Tycho Bomber, good looks on the follow. How are we doing today? Welcome to the stream, my good friend. We're going over, as you could probably see, we're going over IPv version 6. My head is going to be hurting today. Welcome to the stream, my friend. How we doing out there? So have you if this is your first time to the stream, pretty much I'm gearing up and studying for my CCNA 200-301 exam. We're about halfway through all of the study material for the exam, and it's been a pretty intensive study. I don't know if you've ever if you have or have not ever looked into the CCNA exam itself, what it is, what it means, and stuff like that. It's pretty much the Cisco Certified Network Associate exam. So Cisco networking devices, routers, switches, IP fundamentals. It gets into obviously wireless technology, and then it kind of ends with automation, automating like Ansible and stuff like that. Just slightly talks about those subjects, but that's where we're at. There's a couple things that we use as well. I use Cisco Modeling Lab. If you're familiar with anything that's Cisco related, this Cisco Packet Tracer. Cisco Packet Tracer is awesome. It's an awesome network simulating tool, and I use that as well. And we again, Cisco Modeling Lab is the emulated type of version, which uses actual real images to do it. It's all virtual and stuff like that. And I've got some integration between Discord and the actual stream here. Is that like Wireshark? No, Wireshark is a capture packet program. So Wireshark, you would implement Wireshark inside of a network, like say on my PC. I would open up Wireshark and I would start capturing packets that are in my network. So that's what Wireshark does. So if I wanted to look at, what's going on in my network, I would look at Wireshark, and Wireshark would start capturing packets that are being flowing through my network, okay? At least the network that I'm attached to. And then I can look at those packets, see what information is going through. There's other things you can do with Wireshark. Some things that, good things and some bad things, whatever. But what I'm talking about is virtualization technology. So I have even though my server timed out, it's still up and running. But I have a server that I use. If you've ever heard of GNS3, so Cisco Modern Lab is what you're supposed to purchase to actually use GNS3. A lot of people misunderstand that about GNS3. I have GNS3 on my server as well, but I prefer to use Cisco Modern Lab. And what it is again, it's virtualizing actual Cisco networking images. So these are legit router images. These are legit switch images and stuff like that I use that because I want to know, because it's the closest thing I can get to besides actually using real gear. So obviously real gear can get expensive, and you know what I'm saying, and I just don't have I don't have the money to afford real gear. I don't have the room to implement real gear and stuff like that, and it's just easier for me to do everything virtual. Okay, so instead of me using, again, does it cost a lot to buy a setup? So a legit setup, like real gear setup, you can get probably used stuff. You know what I'm saying? You can probably get a used Cisco router for about $400 or $500. A used switch, again, for about $300 to $400, depending on if it's a layer 2 switch or a layer 3 switch. You know what I'm saying? To get the most out of it, you would probably, at least the most learning out of it, you want to go with a layer 3 switch. So again, you're talking $300 to $400. And then, so that's, so now you're talking about $600-700 for that. And then if you want to have it set up on a rack, obviously you got to buy the rack and whatnot. The racks ain't that expensive. Probably a rack will get you about $100 back. So now we're about $800 right there. And then implementing the wiring and all that stuff. So you're probably talking about oh no, the VM setup as in the cost of VM setup GNS. So GNS3 is actually free. GNS3 is free, but the caveat to GNS3 is you need to purchase a Cisco Modern Lab license to actually use GNS3. Even though GNS3 is separate from Cisco, GNS3 does its own thing. You need to purchase a Cisco Modern Lab license. Now, a Cisco Modern Lab license is only $200 a year, okay? $200 a year, and I can run a virtual server, okay, and implement all of this stuff. So instead of a cost of like $800 to $900 with real gear, I'm only down $200 for virtualization technology. All right. Now my server, I did purchase. I do own my own actual server, and that's a virtual server though. Okay, it's not a hardware server. It's a virtual server. And I purchased that. That's an EXXI server. So if you're familiar with like Proxmox or anything, so I virtualized that on top of a virtualization program called VMware. Okay, so VMware allows me to virtualize bare metal images on top of my actual PC. All right, because what I'm doing, a link for. Give me a little bit more context. A link for Cisco Modern Lab GNS3. Which one do you want a link for, my good friend? I'll get you whatever link you want. Just give me a little bit of more contents. So yeah, like I was saying, So again, everything I run is virtualized. And that's how I'm able to, because I do other things as well. Like I run multiple Linux operating systems and stuff like that for automation. Again, yeah, the Cisco lab and what one the cost about and what one that cost about. So Cisco Model Lab, yeah, $200. So here I'll get you. Let me go to my thingy real quick, and I'll get you that link right now. Okay, that's fine. I won't log in, but I'll get you the link to it though. So HTTPS colon software. And then, so that'll get you, you're gonna have to create a Cisco account and all that stuff. And then obviously the caveat to that is I run everything off of VMware. So yeah, we'll look up VMware. Oh, you have VirtualBox. Okay. All right, you have VirtualBox, so you can do it. You can do it on VirtualBox too. Yeah. Hold on, let me think. Let me think. Yeah, you should be able to do it off of VirtualBox. Let me just think about that for a second. Make sure there's not going to be any issues for you. I want to say you should be able to do it off of VirtualBox. It is suggested to do it off of VMware, Workstation, but I believe you can do it off of VirtualBox. I might want to, I may have to look into that for you. I may have to look into that for you. I may have to look into that for you. Because there was, again, you may be able to do it off of VirtualBox, but there may be an issue with VirtualBox not being able to do that. Because it is suggested that you use at least VMware like Player or something like that to run those types of the software emulators. But again, you should be able to do it off of them. Yeah. yeah, like I said, so the Cisco Modern Lab, again, to be able to use like GNS3 the right way, you need to purchase the Cisco Modern Lab license, and obviously you need a Cisco account and stuff like that. But once you own the license, okay, and it's a $200 a year subscription, okay. Once you own that subscription license, I would suggest just using Cisco Model Lab. It is a way better, at least in my opinion. I love it. It is a great program. Um, you know, you don't have to go chasing after all kinds of images like you would normally with GNS3 and stuff like that. It comes with base images. You know, we have I have Ubuntu server already built into it. I have all the other you know, devices, the cloud service router, the iOS V, the iOS LV. So this is the switch image, the routing image, and then some of the other different types of network images, the ASA. So this is like the firewall. We have some traffic emulators here, and then obviously, so we have an unmanaged switch, and then some different type of operating systems. These are all Alpine Linux operating systems and whatnot, and stuff like that. So again, you need to just know some basic stuff about virtualization. You need to know the kind of actual hardware you're running. All right. So I'm running this off of 6 CPUs. So 6 actual CPUs I've actually have to I'm allocating to running this, okay? 6 CPUs and 32 gigs of RAM. That's just to run this emulator. Now, if you can afford, that's why I'm saying you need to know the kind of hardware you're actually running, because you need to have X amount allocated to these emulators for them to even run properly. Because if you don't have enough resources allocated to it, it's either going to continue to crash or it'll just run extremely slow. And I'm talking, you'll sit there for about a half hour waiting for something to load. So you need to know the actual kind of hardware you have on your base computer. You know what I'm saying? It's not like running a Linux VM that only requires one CPU and you know a couple megabytes of RAM to get it to at least function. You know what I'm saying? These emulators are a lot heavier. They're heavy programs. They're heavy operating. Yeah, I mean they're all Linux. This is a CentOS. I mean it's a CentOS VM, but it requires a lot because it's obviously using like KVM to run these virtual images on top of inside of itself. You know what I'm saying? And that's why you need to have the appropriate resources allocated to it. But yeah, cool beans, man. Yeah, I mean, if you want to join my Discord server, I have additional information and stuff like that in my Discord. We can kind of take this conversation off into the Discord later on too. So if you do exclamation point, yeah, okay, yeah, no problem. If you do exclamation point on Discord and chat, you'll get the invite to my Discord. And I have, again, we can take this conversation on to the Discord, and I can try to, help you out whatever you need help with when it pertains to stuff like that. And I also have additional stuff on there too, more information and stuff like that too. Yeah, so there you go. Check it out. Obviously, there's a rules things that I just ask everybody to read and agree to, and then on the welcome, you can add different roles and stuff like that to yourself on the welcome page. You know what I'm saying? If you want additional notifications and stuff like that. Not everybody likes the Discord notifications, so I broke that up. And I took it off of the everyone because I've joined multiple Discord channels, and sometimes I don't like getting the 1001 Discord notifications, so I've broken it all up so you guys can choose whatever notifications you want, and that's in the welcome tab. So it's up to you. All right. let's continue on with IPv6 here. All right, representing the prefix length of an address, IPv6 uses a mask concept called prefix length. All right, similar to IPv version 4 subnet mask, similar to the IPv4 prefix style mask, the IPv version 6 prefix length is written as a slash. All right, followed by a decimal number. The prefix length defines how many bits of a IPv version 6 address defines the IPv6 prefix, which is basically the same concept of IPv version 4 subnet ID. Okay, so again, to get back to some of the I guess kind of like the fundamentals of IPv version 4, IPv version 6 uses a lot of the similar concepts in itself. Obviously, again, we're just dealing with a larger address pool. Okay, instead of 32 bits, we're dealing with 128 bits. Okay. All right. When writing in IPv version 6 address and prefix length in documentation, you can choose to leave a space before the slash or not, as shown in the next two examples. All right, the 2.2.1.1, yep, /64, or the 2.2. Yep, space 64. So again, when writing an IPv version 6 and prefix length in the documentation, you can choose whether to leave a space before the slash or not. So it's just saying you can choose to leave a space or not. It's up to you. All right. Finally, note that the prefix length is a number of bits. The prefix length is a number of bits. So with IPv version 6, the legal value range is 0 to 128 exclusively. All right. So 0 to 128 exclusively. Okay. All right. All right. Calculating the IPv version 6 prefix, so the subnet ID. All right, the subnet ID. With an IPv version 4, you can take an IP address and the associated subnet mask and calculate the subnet ID. With IPv version 6 subnetting, you can take an IPv version 6 address and the associated prefix length and calculate the IPv version 6 equivalent of this subnet ID and IPv version 6 prefix. Okay, like with different IPv version 4 subnet masks, some IPv version 6 prefix length makes for easy math problems to find the IPv version 6 prefix. While some prefix lengths make the math more difficult, this section looks at an easier case, mainly because the size of the IPv version 6 address space lets us choose to use the IPv version prefix length to make the math much simpler. Okay, much easier. Finding the IPv version 6 prefix. All right, and in an IPv version 6, a prefix represents a group of IPv6 addresses. For now, this section focuses on the math and only the math for finding the number that represents the prefix. Chapter 23, IPv version 6 addresses and subnets, then starts pulling more meaning behind the actual number. An IPv version 6 prefix or subnet, if you prefer, has a number that represents the group. Per the IPv version 6 RFC, the numbers itself also called the prefix, but many people just call it the subnet number or subnet ID, okay, using the same terms as an IPv version 4. Okay, so some people, again, prefer to revert back to the same terminology as when they learned originally the IPv4. Okay, so again, we can kind of use some of these terms synonymously between each other. Okay, all right. As with IPv version 4, you can start with an IPv version 6 address and prefix length and find the prefix with the same general rules that you use in IPv version 4. if the prefix length is /p. So prefix, all right, represented by the P. Use these rules, all right? Woo! I scrolled too fast. Okay. Copy the first P bits, okay? So the first whatever bits, okay? P equaling whatever your prefix length is, okay? All right. Change the rest of the bits to 0, okay? All right. When using prefix length, that happens to be in the multiple of 4. You don't have to think about the terms bits, but in the terms of hex digits. A prefix length that is a multiple of 4 means that each hex digit is either copied or changed to a hex 0. Just for completeness, if the prefix length is indeed a multiple of 4, the process becomes identifying the number of hex digits in the prefix by dividing the prefix length, which means is in bits, by 4. Okay, copy the hex digits determined to be in the prefix per the first step. Change the rest of the hex digits to 0. In the figure shows an example with the prefix of 64. In this case, step 1 looks at the /64 prefix length and calculates the prefix has 16 hex digits. Step 2 copies the first 16 digits of the IPv6 address, while step 3 records the hex zeros for the rest of the digits. All right. So again, that goes to what would be the advantages of setting up subnet IDs if IP has trillions of IPs that are assigned? What would be the advantage of setting up subnet IDs? Yeah, I mean, so honestly, the advantage to splitting up anything on separate subnets is to pretty much separate anything. Like say you had different departments, all right? You wanted to just maintain certain departments on a certain subnet, then you would allocate that department to I trust me, I know exactly what you're saying. IPv6 has, we were just looking at, has 10 octillion addresses. You can't even think about that number. That number is so big. But I guess, the logic would still be similar to how you think about IPv4, okay? You could take you could take a class A IPv4 address, the 10 dot, the private, the 10 dot class A network, and just use that entire network for your addressing, okay? But if you had to split anything off on a different router, obviously you got a subnet. All right? Say you had department over here, all right, and they were off on a possible different router or a possible different VLAN, what have you. You're gonna have to have that subnetted, okay? So that's the same logic. So the logic still is the same of when we're thinking about IPv4 to IPv6. And this is the kind of discussion I had in the beginning of the stream, where I was saying was, for the most part, in the private domain, so our houses, our small businesses and whatnot, I don't believe we're ever going to get rid of IPv4, just because it's just easier for us to think about, and we don't need the 10 octillion addresses in our small business or in our house or whatever have you. When we get to the enterprise level, again, for the most part, they could still use IPv4 inside of their private domain, all right? Some companies, though, are choosing to go with the IPv6 address scheming, or even in their private domain, all right? But the logic is still sound from where they have, from IPv4 to IPv6 is, again, when we're separating things by a router when we're creating different VLANs, we need to be using subnets. So that's that same type of logic. It still corresponds from one to another. All right, it's just apples to apples. It's apples to apples again. It's apples to apples when we're talking IPv version 4 and IPv version 6. We're just obviously using a ridiculously huge number in comparison to IPv version 4. IPv version 4 is huge already. I mean, what do we got? With IPv, the most addresses we have with an IPv version 4 is 4 billion. 4 billion addresses. 4 billion addresses we can get within. But I mean, then that's classing it all the way down to absolutely nothing. But there's like 4 billion addresses in a complete IPv4 address range. But talking about a Class A, we have 16 million addresses in a Class A network. So 16 million in just a Class A network. Okay, again, huge. All right. All right. So in this example, again, it's just going over how we need to think about when we're looking at an IPv version 6 address here. Okay. Each one of these, so each quartet, because I don't want to start. So when we're talking IPv version 4, it's octet. When we're talking IPv version 6, it's quartet. Quartet. All right. So 0. Man, I keep drawing these too big because I'm still thinking IPv version 4. 1, 2, 3, 4. Colon, 1. 2, 3, 4. Colon, 1. 1, 2, 3, 4. Colon, 2, 3, 4. Colon, 2, 3, 4. Colon, 1. 4, 5, 6. 1. All right. So in each quartet here, all right, there's 16 bits in each quartet. Okay. All right. So I mean, again, if we get all 16, all right, so 16 times 8, 16 times 8. I mean, we can do it on a calculator. I'm horrible. I might be good at this stuff, but I'm horrible at simple fucking, excuse my language, horrible at simple math. So 16, 16, 16, 16, 16, 16, 16, 16. All right, you do that. That gives you the 128 bits in that IPv version 6 address. Okay. So again, when we're dealing with prefix masks in an IPv version 6 address ranges, all right, each quartet is represented with 16 bits. Okay. All right. And then again, obviously inside of those 16 bits, each one of these, all right. So if we break down that, I mean, we can continue to break this down. That's how we get so many different addresses here. Okay. But that's how we start, at least with our thoughts about how we start doing subnetting with IPv version 6 here. Okay. All right. Creating the IPv version 6 prefix and address length. After you find the IPv version 6 prefix, you should already be ready to abbreviate the IPv version 6 prefix using the same rules you use to abbreviate the IPv version 6 address. However, you should pay extra attention to the end of the prefix because it is often at the end of the prefix because it is often has several octets of the 0 value. Okay. As a result, the abbreviation typically ends with 2 colons, colon, colon. Okay. For example, consider the following IPv version 6 address that is assigned to a host in a LAN. Okay. So what do we got? all my courses are ended. The example shows the IPv6 itself cannot be abbreviated after you calculated the prefix length in which address resides by the zeros out of the 64 bits, 16 of the 16 digits of the address. You find the following prefix. Okay. So again, let's do this. Let's do this problem real quick. Let's do it on the board. We'll do it right on the screen, actually. So we'll do it right underneath it. So we have, and we'll do it in two different colors. So 0, 0, 0, colon, 1, 2, 3, 4, colon, what's the next one? 5, 6, 7, 8. All right. And where's our, we have /64. So we need to find 64. So 16. All right. So 64. Again, we would find ourselves, let me see, right here. All right. So we would find ourselves in the fourth quartet. All right. 9. ABC, right? ABC. All right. Colon, and then let's change the color, and then the rest of these 1, 2, 3, 4, 5, 6, 7, 8, and then it's just the same 9 ABC. All right. So 1, 2, 3, 4. Oh, I missed a colon right there. So that would be, so obviously network and then host bits. Similar to how we would be looking at, and it shows you exactly right here. And then abbreviated down, and it's following. So similar to how when we think about finding the subnet ID for an IPv4 address, okay? So when we're looking at a IPv4 address, okay, say we have the 2 for 5, we'll just use 2 for 5, dotted decimal notation, 0, 0, 0 here, all right, and then say we had an address 172.16, you know what I'm saying, 95, whatever, 85, okay? This obviously would be the /16 subnet mask, okay? And if we wanted to find the subnet ID for this address, okay, with the rules, since the first 2 octets obviously are filled with 8 binary ones, all right, and the last 2 octets of the dotted decimal notation is full of 8 binary zeros, all right? To find the subnet ID for this address right here, the 172.16.95.85, all right, what will happen is the rule is these 2 octets, since these octets are full, the mask is filled with binary zeros, this would be 0, 0, 16, 172, okay? So the subnet ID for that address 172.16.95.85 would be 172.16.0.0. The same logic is applied to IPv6, as we can see right there. Given the fact that the 2000, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABC colon, all right, then would be 0, 0, 0, 0, 0, 0, 0, 0, all the way to the last 4 quartets of that address range, all right, and then it can obviously then it shows it can be abbreviated down, but they're simply showing the :/64, okay? So it's the similar type logic as we would generally be using when we're talking about an IPv version 4 address here. All right, again, just like in an IPv4 address here, same thing here. All right, the octets that are going to be filled with binary zeros to find the subnet ID now. Okay, the subnet ID obviously are going to be with binary. Obviously, you're going to turn into zeros. Okay, same logic is sound. All right, and then it's just covering that could be abbreviated down by using the colon. Okay. All right. All right. You abbreviate the 4 quartets all with the as follows. Cool. All right. To get better at the math, take some time to work through finding the prefix of the several practice problems as listed in the table. The answers sit at the end of the chapter in the section answers to the earlier practice problems. All right, cool. So we can let's take a swing at some of these real quick. We'll try to blast through that. All right, we'll keep this on the board just as a good visual cue. Yeah. All right. All right. So, what do we got? So we got 2, 3, 4. So we would start with this one: 2, 3, 4, colon, 0, colon, 10, colon, 100, colon. All right, 1,000, colon. All right, A, B, C, D, colon, 101, colon, 101, 10, colon, /64. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8 octets. Okay, we have the slash notation, the prefix of 64. All right, again, 64 gets us 1, 2, 3, 4. All right, 4 times 16 is 64. So the first 1, 2, 3, 4, the first 4 are quartets here. So this would be abbreviated to 23. All right, 0, 10, 100. All right, and then remember, all these turn now into 0. So this would be colon, /64 now. Okay, so the answer would be 23, 40, colon, 0, colon, 10, colon, 100, colon, /64 now. Okay, all right, let's do the next one. 30, alpha. A, B, C, D, colon, echo, foxtrot, colon, echo, foxtrot, colon, 3, 4, 5, 6, colon. All right, 1, 2, 3, 4. All right, and again, we don't have to write out the rest of it, colon, /64 now, okay? Because remember, we're just taking the first. We just need the first 4 quartets here. So 1, 2, 3, 4. All right, colon, 64. This would be our subnet. This could even probably be abbreviated. Yeah, this could actually be abbreviated down. I believe I can get rid of that 0 right there. I believe I can. All right, same thing on the next one. So that would be 2, 2, 2, 2, colon, 3, 3, 3, 3, colon, 4, 4, 4, 4, colon, 5, 5, 5, 5, 1, 2, 3, 4, colon, /64. All right, again, there we go. There's that one. All right, now because now it's going to try to trick us up. We have an abbreviated address here, so now we have to pretty much find out where the abbreviation is in this address in it. Okay, so what do we have? 1, 2, 3, 4. All right, so it's only showing us 4 quartets. So what it's pretty much stating is that in here, so let me see, 1, 2, that's ending there, so that's 3. So in here, there were some leading zeros that were abbreviated out of this IPv6 address range. Okay, so we need to find that. So let's complete that. Come over here. We can actually, I'll write this one down so we can take a look at it. So we got 3210 colon 1234 colon 1234 colon. So 3, 4, 5, 6. So we need 2 more. 1, 2, 3, 4. 1, 2, 3, 4. All right. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. So colon, and then we have ABC, A, B, C, D, colon, 0, 101, colon, 10, 10. Yep. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then obviously with the /64. And then what would happen is then we would take this, and then we would look for, again, the first 4. So 1, 2, 3, 4. All right, octets, quartets here. So our subnet ID would be 3210. All right, and then again, I believe because these are all leading zeros here, I believe I can just get rid of that. And then this would be a /64, like that. All right, and I believe that's a correct addresses. I believe it is. I might be wrong, but we're gonna go with that anyways. All right, so let's write that down here. That way we can save that, so we can take a look at that. We can take a look at that once we get to the end of this chapter here. Okay, so let's write that down: 3210 colon 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 /64. All right. All right. Anybody have any questions so far about what we're talking about? If so, make sure you guys hit it up in chat. And we're just gonna keep on plugging away here. All right. So let's check out this other one. What do we got? All right. We have the same thing. So we'll set up the problem exactly the same way. So 1, 4, 5. So it's showing us 5 quartets. So that means we have 3. So we have 3 leading 0 quartets here. So 24, 0, Foxtrot, colon, 1, 2, 3, 4, colon, 1, 2, 3, 4, colon, 1, 2, 3, 4. All right, colon, all right. That's 1, 2, 3, 4, 5, 6, 7, 8. Cool. And then Charlie, 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 colon, Baba, Babo, Babo. Put a semicolon. I don't want a semicolon. I did another semicolon. Nine colon. Okay. So again, we're looking for the 64 mask. So we're looking for the first 4 quartets here. So the first 4 quartets would be 21, 0, Foxtrot, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. All right, giving us this as our answer. So it would be 21, 0, Foxtrot, and then colon, colon, /64 here. All right. So that would be, again, our subnet ID. Okay. So what do we got? 21, 0, Foxtrot, colon, 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 /64. And what do we got? We got some more. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're good there. We got a /64 again. So again, we're just looking for the first 4 octets. So 1, 2, 3, 4. All right. So our address again would be so this would turn into 34 Bravo Alpha colon Bravo, colon, Bravo, colon, /64. Now I believe again I can remove that 0. Just like that. /64. All right. Yep. So this one would be 34 Bravo Alpha colon Bravo colon Bravo colon 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 /64. All right. And again, I think I could have removed this 0 here. All right. I think I could have. We'll find out. All right. We have another one now. 1, 2, 3, 4, 5, 6. Okay. Let's write that one out too, just like we did the other ones. So 3124 colon 1234 colon 1234 colon dead half 00 fox colon fe 00 colon 1 2 3 1. Okay. Now again, we're just looking for the first 4 octets here, quartets I mean. I keep saying octets by accident. I apologize. And then this again would give us the 3 1 2 4 colon. Now again, I think we can get rid of those. So colon colon. All right, and then dead. /64. All right, and that would again will give us that subnet ID there. So 3 1 2 4 colon 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 dead colon 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 /64. One more. Write it out one more time. 3 Bravo Charlie Delta colon and then 1 2 3 4 5. So that's 1 2 3. Oh, that's smiley faces. Oh, 1 1 2 3 4 1 2 3 4 1 2 3 4 face colon beef colon Phoebe colon calf. All right, and again, we're just looking for the first 4 octets, given the fact that we have a /64. So 1 2 3 4. Okay. 1 2 3 4, and then giving us the subnet ID 2 Bravo Charlie D colon colon a colon colon. I believe that's right. I might be wrong on this one. I might be wrong. Could just be colon colon. /64. All right. So I think it's all. We figured we got. I think we got them all. I think we did pretty good on these. We'll find out at the end of this chapter here. All right. We'll find out at the end of this chapter how well we did. But again, I think we have the concept here of how to take an IPv6 address, abbreviate it, unabbreviate it, find the prefix, the prefix subnets. Okay. Again, this is just going very easily off the prefix. They haven't given us harder prefixes yet. I believe when we continue on here, they're going to give us harder when we get into the subnetting portion, the real subnetting portion of this this part. It's going to hit us with harder subnetting questions. It's just giving us a general review of what we're doing here. All right, and then here we go. So working with more difficult, just like I was just saying, with more difficult IPv6 prefix lengths. Some prefix lengths make the max defined prefix very easy. Some mostly easy, and some require you to work in binary. If the prefix length is a multiple of 16, the process of copying part of the address copies entire quartets. If the prefix length is not a multiple of 16, but is a multiple of 4, at least the boundary sits at the edge of the hex digit, so you can avoid working in binary. Although the /64 length is fairly the most common prefix length, you should be ready to find prefix when using a prefix length that is in any multiples of 4. All right, in this for the example, consider the following prefix length. All right. So what that is pretty much stating is again in multiples of 4. So each I hope I'm saying this right. Each bit here, all right, is in the multiple of 4. So 4, 4, 4, 4. Obviously 8, 12, 16. Okay, and that's how we're getting, yeah, because each one's a byte, a bit equals 4, something like that. I get confused over that sometimes. And that's what we're saying. So so it's hitting us with the 56. So if we needed to find the 56, so again, let's just look at it. 16, 16, so we have 32. And then we have 48. All right, so 48 gets us to here. All right, so 48 plus 4, 4, 4, 4. So let's find out somewhere in here where we get to 56. So 48. So this gets us to what? 52. And then this bit right here gets us to 56. Okay. So in here, this is where, so halfway through that 4 quartet, that's where the prefix 56 lives, is in this area right there of that 4th quartet there. It lives in that halfway part. Okay, so that's how we're finding that prefix length of our quartets here. Okay, so if we were to take this address here, and let's do what we did before. All right. Do we have anything being abbreviated? Nope, we don't. Okay, very good. It makes it easier for us to do this. So let's take it. 2000. 1, 2, 3, 4. 56. 78. Okay, now we're on the 3rd octet. Now remember, now it's 9 alpha ::/56. Okay. All right, because then everything after that now is obviously like the host biddies. Okay, again, and it actually gets into that right there. So again, so it's pretty much stating that everything here is then after that host, just like an IPv6. This is everything after that turns into picks up the 0, the binary 0. Okay, and then obviously these turn into 0, 0, and then at the end, just like our address right there, we end it with the : /56. Okay, all right, pretty good. I hope everybody so far is understanding how we're getting that. All right, from where we're at right now. All right, it's pretty easy. All right. This abbreviation is not correct because of the This abbreviation is not correct because it removed the trailing zeros at the end of the fourth quartet. If the expanded abbreviation value, it would begin with if you expanded the abbreviation value. So be careful when abbreviating when binary is not the edge of a quartet. Once again, some extra practice. Okay. Oh, okay. Oh, okay. So it's saying that abbreviated value is not correct. I get that. Because of the trailing zeros. Ah. I get that now. All right. So that's cool. So what it's saying is because of the abbreviation portion with the double colons at the end, like you would with everything else we've been doing so far, because it's at the border, you still have to add those 0 zeros to that address, so that abbreviated representation doesn't get misrepresented by removing those trailing zeros from that address. Okay. All right. All right. Very good. All right. So we learned a little bit. So once again, some practice. Multiples of 4, but it's not a quintet, but not in the, so just extra practice. All right. All right. So let's finish these ones off, guys, and we're nearly there. All right. So let's find out. So we have 80. So again, where's 80 fall in the representation of our values here? So we have 64, and then 70, right? Yeah, 64 to 16 plus 16. Man, I am like, sometimes my brain is like broken, I think, guys. I swear. Yeah. My brain is like half broken. I don't know what's wrong with my brain sometimes. All right. So let's do this one real quick. So we have 34, Bravo Alpha, colon. Again, let's write it out so we can take a look. 1, 2, 3, 4, Bravo, colon. 1, 2, 3, 4, Bravo, colon. 1, 2, 3, 4, colon. 5, 5, 5, 5, colon. 1, 2, 3, 4, colon. 6, 0, 6, 0, colon. 0, 7, 0, 7 / 80. Okay. Now, 16, 16. So 16 plus 16 plus 16 plus 16 plus 16 is 80. So we're looking in the fifth quartet. So we're looking in the fifth quartet. So 1, 2, 3, 4, 5. Okay, 5 right there. So our address now would be, for these ones, okay, be 34, Bravo Alpha, colon, and then what we got? Bravo, colon, Bravo, colon. Yeah, I don't know if I can remove that just yet. We'll find out. And then 5, 5, 5, 5, 5, 5, colon, / 80. We probably could. All right. Now let's write that down real quick on our board. We'll separate that. So then we can take a look at our answers when we get to the end of this chapter here, guys. I'm curious to see how I did with these. 4, colon, / 80. All right. And I'm throwing my mouse around. Okay. Do this one next. 3, 1, 2, 4. What we got? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4. Colon 1, 2, 3, 4. Colon 1, 2, 3, 4. Colon. Dead. Colon calf. He loves using the dead calf. It's freaking me out. Okay, 1, 2, 3, 4, 5, 6, 7, 7, 8. Okay. So again, we're in the 80. So we're looking for the fifth quartet again. So 1, 2, 3, 4, 5. Yep. Giving us the address. 3, 1, 2, 4. Colon. I'm just gonna abbreviate that one out. I'm pretty sure I can abbreviate those zeros out, guys. Yeah, I'm pretty sure I can abbreviate these zeros out. So I'm just gonna abbreviate that out. All right. Yeah. All right. Same thing here. I'm just gonna abbreviate that. And then this one is 3, 1, 2, 4. Colon. Dead. Calf. Colon. Slash 80. Okay. All right, we're doing pretty good. Do the next one. 2, Robbie, Delta, colon. What do we got? 1, 2, 3, 4, 5. So we need 1, 2, 3, 4. Colon 1, 2, 3, 4. Colon 1, 2, 3, 4. Colon face. Colon beef. Colon BB. Shady. Again. Oh, slash 48 this time. Okay. Just got confused there. Okay. Very good. I'm glad he changed it. All right. So 848. So again, remember we need to be looking for where we're at. So we got 16, 16, 32. Okay. Plus 16 gives us 48. So we're in the third. So we're gonna be right here, guys. And the third octet, the third quartet. The third quartet. Okay. So 1, 2, 3. Giving us the 2 Bravo Charlie Delta // 48. Okay. Write that down. 2BCD : /48. Next one. 3 feds : what do we got? 1, 2, 3, 4, 5, 6, 7, 8. All right. We can kind of just like narrow this one down already. Foxtrot. Echo 0. : /48. Very good. All right. Easy, guys, right? We're getting the concepts, right? guys are understanding. Again, we don't know if we're correct yet. We'll have to find out at the end. I'm excited about this one. Colon, 48. 40 now, so what do we got? So the next one's going to be 40, guys, okay? So, again, 16, 16, 32. All right, remember 4, 4, okay? So what do we got? 32, 36, plus 4, so we're right here. So we're in the middle of that third quartet. So we're in the middle of that third quartet, okay? Let's write out this address, though. Let's write it out all the way on this one, guys, so we can take a look at where we're at. 4, 1, 2, 3, alpha, 1, 2, 3, Bravo, 3, Charlie, 4, 9, slash 40. All right, now let's take a look again. What we're going to be doing. So again, we're right in the slap dab in the middle of that third quartet there. So right there, guys. Okay. So 210 Foxtrot colon 000 0 alpha colon 00. Okay. Write that out. Okay, so that'd be 21-0 Fox colon alpha. All right, and then we can abbreviate those last yeah, because they're heading, we can abbreviate those out. Yeah. Slash 40. Okay. Yep. Yep, perfect. All right. So let's write that one down. 210 Fox colon alpha colon slash 40. All right. Only got 3 more to go, guys. We're doing pretty good. And 36 now. So again, we'll be in this other quartet. So we'll be in the first quartet and the third one. So let's write it out so we can take a look at what we're looking at. 1, 2, 3, colon, and then 1, 2, 3, colon. And again, remember, we're in only the first now, since it's the slash 36. So we're only going to that first digit in that third quartet. All right, so this is where our address is lying right there, guys. Okay. All right, so that'll be represented by 34 Bravo Alpha colon B. All right, and then colon and then slash 36 here, guys. Okay. I'm running out of space over here on my body board. All right, 34 Bravo A B colon slash 36. Let's do this one. 60. All right, remember 60 again. So where do we find 60? So 16, 32, 48, and then 64. All right, so if we were, again, to take this off right here, we would be falling into the we'd be falling into the third hex digit in our fourth octet here. All right, giving us 60 right there, guys. Okay, so the third hex digit in our fourth quartet. All right, let's write this one out. 1, 4, and 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4. 1, 2, 3, 4. Dead. Cap. 1, 0, 0, FF. Colon. E. FE. 0, 0. Colon. 1, 2, 3. All right. And again, we're falling into the third quartet. The third digit in the fourth octet. So 1, 2, 3, and then the third quartet. Okay, the third quartet there, guys. Okay. So our address would be 3, 1, 2, 4. And then we can abbreviate those zeros out, and then DE. Okay, colon colon /60. All right. So 3, 1, 2, 4, colon, 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 DE, colon, 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 /60. All right, one more left, and we're going to take a look to see how we did. And this is again a /56. So remember that we're going for the second hex digit on that fourth quartet there, guys. So 2, Bravo, Charlie, Delta. How many have we shown? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4. 1, 2, 3, 4. 3, 1. Good. Let's find where we're at now. Again, we're going for 56. So that's the second. Remember the second hex digit in our fourth quartet. So 1, 2, 3, and then 4. Right there, guys. All right. So we're going with 2, Bravo, Charlie, Delta, colon, colon, FA, colon, colon, /56. All right. All right. Any questions so far on what we just did? Now, we're going to have to see if I'm not full of baloney sticks or not. All right. Now let's go check our answers, guys. Chapter review, some key topics. Yep. So we just went over the similarity between IPv version 4, IPv version 6. We went over the rules of abbreviating IPv version 6 addresses, rules for expanding abbreviated IPv version 6 access, process steps to find the IPv version 6 prefix based on IPv version prefix length. Some key terms we went over, IPv4 address exhaustion, IPv version 6, OSPF version 3, ERGRP version 6, prefix length, and quartet. All right, now let's go over the abbreviations on, see how we did. Oh, so you can't remove that. Okay. So remember how I removed that 0? Why does that one look all messed up in comparison to what I got? Did I erase more? Oh, wait. That's the abbreviated. Oh. Wait, we already went over that. Okay. I'm like, what the heck did I do wrong? All right, so you can't remove that one. All right. Bummer, because I kind of went along with that. All right. I shouldn't have went back and did that because that I guess is wrong. So can't remove that 0, so we have that there. But for the most part, we got that one right. 3 ABC, 1 2, 3 4 5 6. We got that one right. 2 2 3 3 4 4 5 5. That's good. 3 1 2. Yep. And then 3 BA B colon good. And then all right. So that's one thing we cannot do is we can't remove those zeros from that. Okay. So that's one thing we should keep in mind then, is we cannot move those zeros from the middles. If that's the case, then I need to refix that one. There's a couple of them. All right, so we cannot remove those zeros from our abbreviations here. All right. Oh, snap! Who do we got as a follow? Let me look at my board. Popcorn! Welcome to the stream, Popcorn. How we doing? Let me take a better look at my thingy. Popcorn Classics, welcome to the stream. That's how I look at my notification things. How we doing? All right. So there's one thing. I lost where I was at. What's up, dude? I'm doing good, my friend. Going over some IPv6. Woo woo. Everybody be loving some IPv6. All right. So yeah. So okay. So we can't be removing those zeros from it. All right. And then the last one's good. Let's go to the next one now. 3BAB. Again, we can't be removing those zeros. That's one thing I got to remember. So no more is we won't be removing those zeros no more. Again, we can't be removing those zeros. All right. Good. So that's one thing I just learned, is we can't be abbreviating out those zeros, even though it's because we're abbreviating out all the other zeros and gathering from the end of that IPv6 address is the reason why we can't be abbreviating out the zeros inside of it when we're dealing with that subnet ID. Okay. So which one did we just look over? ABC, and then we got Fed, good, FA, good, and then FABA, good, and then again we can't be abbreviating those zeros out. All right. The last one. I see what I did wrong. I did that wrong again. I did a couple of them because I removed the zeros from it. So these last two right here, where they ended in actual zeros, the trailing zeros, I removed the trailing zeros. So we got the last two ones wrong. I'm gonna tell myself I got the last two ones wrong on that one right there, because I removed the trailing zero. We can't be removing trailing zeros when we're abbreviating these IPv6 addresses. All right. So we got two wrong. All right. So, Popcorn, I don't know if this is your first time to the stream. Welcome, my friend. What I'm doing, what the stream's about currently, what the stream's about is I'm going after the Cisco CCNA certification. That's the Cisco That's the Cisco Certified Network Associate certification. This is pretty much a study stream that we go over everything CCNA. I use multiple virtual machines to do some of the emulation and simulation that goes along with networking devices and whatnot. If you want, you can do the exclamation point Discord in the chat. That'll bring you over to the Discord channel. I have some additional content as well that I do in the good work and good luck. Thank you very much, Popcorn. I appreciate that very much. Is pretty much is going to be going into this stream is going to continue past CCNA too, because from here we're going to be getting into DevNet. All right, that we're going to be going after the DevNet Associate certification next. It's going to be legitimately following this, or I'm still trying to make my mind if I can have enough brain power to do that on top of doing this at the same time. Hi, baby. So what I'm trying to examine with myself, if I can do both DevNet and the CCNA studies at the same time, because I want to go after them back to back. So I want to get my CCNA certification and my DevNet Associate certification back to back from each other. So I'm still trying to decide if I have enough brain power to spare to do both. But yeah, no, welcome to the stream, my friend. Thank you for the follow. Shoot, man. Like I said, do the if you're interested in more content, make sure you hit up the Discord. The Discord, there's additional stuff in there as well. I don't know if you do. Let me switch my scenes real quick. Let me switch my scenes. Yeah, we'll go to the intro scene. All right. So we did a really good study today. We covered the what is this, chapter 22. So we covered all of chapter 22. We went over the concepts, the beginning fundamental concepts of IPv6, which is good. Tomorrow we'll be back here again at 5:30 p.m. All right, Eastern Standard Time. 5:30 p.m. Eastern Standard Time. We're going to be going IPv version 6 addressing and subnetting. All right, I feel as though I'm really confident with what we actually went over today. I'm actually feeling really good about IPv6 now that we just reviewed that chapter. So tomorrow we'll be getting into addressing and subnetting. We're going to be hitting that a little bit more, going over global, unique addressing here, and then some more stuff. And then tomorrow, let's see. Tomorrow we might make a lab. Yeah, tomorrow we'll lab it up. We'll lab it up tomorrow, guys. In CML, all right. With IPv version 6. Okay, so we'll do some labbing in CML tomorrow. All right, and we'll get through chapter 23 tomorrow, guys. Pretty much this week's gonna be all about IPv version 6. So if you're interested in learning more about IPv version 6, make sure you guys join me all week for IPv version 6. And we'll be hitting these topics hard and heavy all week. So yeah, guys, this has been a good. Today was actually a really good stream today. I'm super pumped up. Again, thank you very much. Shout out to Popcorn Classic and Tycho Bomo. Good looks on the follows today, guys. You guys are always awesome. Always awesome. Again, if you guys are interested in more stuff, make sure you hit up the Discord. I'm on there usually all night long and stuff like that, doing other stuff. Let's go to my other scene. Let me turn on my music. I got to get ready for work, though, guys. I start work at 10 o'clock, and it's about 9 o'clock my time now. So Hold on. Let's make sure that other mic is not on. I have too many microphones. Hold on. No, it's not on. Alright. Hype! Alright, guys. You guys have a great night. I love every single one of you guys. You guys are awesome. You guys are continuing to pump me up and keep me going here. So I'll see every single one of you guys back here tomorrow, 5:30 p.m. All right, and we'll continue on with our studies, guys. All right, but for now, you guys have a good night and a great evening, and I will talk to you guys very, very soon. All right, guys, let's go raid. Let's go raid one of my. Let's go see who's on right now that we can go raid. Let me see who's on right now. Who haven't I raided in a while, huh? Is there really nobody on right now? Yeah, let's go raid. Let's go raid my good friend over here. He helped me out the other day. Well, I'm gonna go return the favor back. I know I don't have as many as he has, but you know what? He's a good dude. He's a really good dude, and you guys should definitely follow him. Alright. Let's go raid my good friend, Master Maestro. He's an awesome dude. He's a super experienced dev netter. He's pretty much what I'm chasing after, guys. Let's go give him a raid. Let's go say hello. Let's go give him a follow. And you guys have a great night. Thank you very much, guys.
It is going to do that. It's going to do that here as well. But both of these things will be evaluated because it's a brand new if statement, okay? A completely new if statement. So both of these things can be true. So it's going to do this first. Then it's going to say, hey, if x minus 5
Hey, honey.
equals 0,
Sorry about that.
go ahead and use your input 10, which is dumb, but we can certainly do that. What's up, Joseph Caffarelli? Welcome to the channel. Thank you so much for the raid. Everyone, come on in. Come on in. Good to have you. We are just finishing up. We're getting super close to the end of our really quick Python coding boot camp. Not really boot camp, just a crash course day so that we can learn how to use Python to use some cool stuff on Wednesday to do an ETL process. But this is basically really quick thrust into coding so that you can understand one aspect of software development lifecycle, learn how to use code for automation when you're dealing with infrastructure. So good. How are you? What were you doing? How was your stream? What were you doing on stream today? How you been? It's good to see you. Don't you mean user input 5? Yeah. The words here don't mean anything. I was just kind of showing you that this was a different method of doing.
You alright, baby?
So we had the ifs and the else ifs, and these are all one block. But ifs start a brand new statement. So every time you use an if, it starts a brand new statement, and that's gonna get run. This if statement is gonna get run in your code. It's gonna get run in your code. So just be careful with what you're. Well, not be careful, but like there's gonna be times when you just use if statements to do certain things, or where you can use if statements, and times when you need to use else ifs and else's to figure out what you want to do. So those are the conditional operators. Only run code if the statement in which I want you to evaluate is true. Okay, only run it then. And if not, go ahead and move on to other stuff. Sure was great. Covered IPv6 fundamentals. First off, I need to go watch that because I tell everyone networking is my weakest. It's one of my weakest areas as a whole through the tech stack. I think networking is one of my weakest. The one that I'm the least confident in, at least. And Sully, he hurt my feelings a little bit. So Philly heard from Phillips a little bit over the weekend after, again, Dorothy did an amazing job of getting her Network Plus cert about people needing to really be really good at networking. And, you know, like I said, I'm not terrible, but I gotta get my skills up. Definitely gotta get my networking skills up. So I may check that out because that would be helpful for me. All right, so those are conditional operations, okay? Control flow. This is how you control the flow of code in your application. And I think we only have one more thing that I want to go over. Oh, no, we have two more things. Two more things, and we'll be done. All right, there's a lot of other stuff here. We're going to go over loops, and we're going to go over functions, okay? Loops and functions. All we're going to do real quick. Loops are going to throw you for a loop, okay? This is going to hurt a little bit because I'm only going to dedicate maybe 8 minutes to this. So a loop. What is a loop? A loop is used to run a set of instructions multiple times. There are different types of loops, a for loop and a while loop. There's also more types of loops than just that. But in Python, you got for loops and while loops. Maybe you have a do while loop in Python as well, I guess. But yeah, loops run for as long as the scenario you specify is true. So we've already talked about setting scenarios. Setting that statement of equality as long as something remains true. Okay? And loops are great. So let's hop right into loops and spend way less time than we should spend on loops.